Let's look at some related things. These are not directly oceanography, but it's good to be aware of these larger backgrounds. So it's essentially the formation of Earth and the solar system. So if you, for example, got into paleoceanography, then you would need to know a lot about geology, geochemical processes, past climate, and many things about the solar system. So the best theory we have is the so-called nebular hypothesis, where all the bodies in the solar system are formed from nebula, where nebula is just a cloud of gases and space dust. So Big Bang happened, many first generation stars formed, they exploded, supernovae, bigger stars, bigger stars, heavier elements, and so on. So the universe is full of this cloud of gases and space dust, and gravity keeps pulling them together. Everything is rotating, so gravity begins to form stars and then planets. So mainly hydrogen and helium are present in these so-called nebular clouds and gases with a little bit of heavier elements. So gravity concentrates the material at the center of our sun, which is mostly hydrogen. It's undergoing nuclear fusion, which produces helium, which is heavier, so the heavier elements increase gravity, so there is a pull towards the center, but the energy produced by the fusion, the heat produced by the fusion is expanding the sun, so sun continues to expand, and in 100 million years, in fact, Earth's temperature should increase so much that all the water would evaporate. In a few billion years, about 5 billion years, sun will basically expand so much and also continuously die along the way, but the planets in the solar system should be completely consumed by this expansion process. So prototypes form from smaller concentrations of matter, what are called eddies, so these little circulation systems. There are gravitational and other aspects of why you get stuck in a orbit around the parent body like the star, and how different sized planets then get distributed within that system that is rotating, that's orbiting around that parent star. So proto-Earth probably was larger than the Earth today. It was some kind of a primordial soup, probably constantly being bombarded by various meteorites and planetoids and so on. And very early on, as we know, moon formed by a asteroid, a pretty large asteroid that collided into Earth, embedded part of it into Earth and took a chunk off, which then gravitationally got trapped to Earth, so it becomes Earth's moon. And the composition was probably homogeneous when it formed, but then so-called density stratification happens. So there is radioactive heat involved to make this density gradient. So there is spontaneous disintegration of atoms and fusion reactions happen at very, very high temperature. So the heat from the contraction itself, when the protoplanet is shrinking because of the gravity, the protoplanet partially melts. So you have the density layer formation and the rotating system with density cooling along the way begins to have density stratification. As we will see in a rotating system, stratification is one of the important things which makes a huge difference in how the circulation gets organized.